The quotient rule is a great tool for finding the derivative of a function that is a fraction, but it can be really hard to remember because it's kind of a messy formula. Well, in today's video, I'm going to show you the easy way that you can remember the quotient rule formula and how you can apply it just as easily. So by the end of this video, you should have a really easy time applying quotient rules to find the derivative of a fraction function. So be sure to stick around to the end so you can get this shortcut down super solidly and apply it yourself. Without further ado, let's go ahead and jump on into the example and I'll show you what I mean. So like I said in the intro, in today's video I'm going to be showing you the one easy trick that you can use to remember the quotient rule and how to apply it. And I'm going to be showing you how to do that with this example here. We're going to find the derivative of this function, y equals sine of x plus 12x all over e to the x. And we know that this is going to have to use the quotient rule because obviously we have a quotient here, we have a fraction, we have this numerator sine of x plus 12x and we have this denominator e to the x. So what I'm just going to start with here is the actual quotient rule formula, and this is actually one of the formulas on my free Calculus 1 study guide. If you want to check that out, there's a link in the description. I also go into more detail about it in my complete Calculus 1 package. Link of that is also in the description. But let's go ahead and just start with the quotient rule formula as you probably have seen it before, and then I'll go into how you can remember it and apply it. So here's what the quotient rule tells us. If we have some fraction, some function, which can be broken up into a numerator and a denominator, and we're trying to take the derivative of that function, we can just do the bottom of that fraction times the derivative of the top of the fraction minus the top of the fraction times the derivative of the bottom of our fraction, and all that is going to be over the entire bottom squared. So this quotient rule formula is nice because what it allows us to do is think of the top of our fraction and the bottom of our fraction as two separate functions, which presumably are going to be easier to find the derivative of. So these f prime and g prime pieces are going to be easier than finding the derivative of the whole fraction as a whole. Now, one thing that I want you to be very careful of when you're applying this formula, notice we have a minus here instead of a plus. So with the product rule, since we had, the product of two things being added together, the order didn't really matter. But quotient rule is different. The order is important. You do need to make sure that you're doing the product of these two things specifically first, and then minusing the product of these two things second. And this formula is great because it makes finding the derivative of a fraction a lot easier, but it's not super easy to remember. So that's the key thing here that I want to point out, is how you can remember this formula so that you can easily apply it yourself. Well, to do that, let's consider a slightly different way of thinking about this. Instead of thinking about our fraction as f and g, or f over g, let's think of it as the high part over the low part. So we have some fraction, some function that is a fraction, where we have the high part being the top of our fraction, the numerator, and the low part being the bottom of our fraction, or the denominator. And what we're going to do is we're going to go ahead and kind of abbreviate this. Instead of writing out high and low, we're just going to say high and low. So the kind of equivalent of this formula in terms of high and low is a little bit easier to remember because it kind of flows off the tongue, kind of makes a little bit of a jingle out of it. So how you can remember this is it's going to be low times the derivative of the high. So low times d high. So wherever we have a d here, that's just the derivative of the thing that follows it. So low d high is just the bottom times the derivative of the top minus high d low, which is just the numerator, the top of our fraction, times the derivative of the low part. And then all that is going to be over low squared. So low d high minus high d low all over low squared. Kind of flows off the tongue a little bit easier, which can sometimes make it a little easier to remember. So this is kind of the version of the formula that I like to basically memorize. So now, similar to when we apply product rule, what we want to do is kind of figure out all these pieces. So we have a high, a low, a d high, and a d low. So basically we can just kind of write them out one by one. So first of all, our high, that's just the top of our fraction. In this case, the top of our fraction is sine of x plus 12x. Then we have the low, which is just the bottom of the fraction, which is e to the x in this case. And then we have d high, which is the derivative of the high. The derivative of sine x is cosine x. and the derivative of 12x is 12, so this is just going to be plus 12. And then we need to figure out our d low, which is just the derivative of the low part, the derivative of what we figured out here. Derivative of e to the x is also e to the x. So these are kind of our four pieces, and now we can again plug them into the formula. So we're going to get low d high, so low is e to the x, d high times cosine x plus 12, and be careful here, you need to make sure to put all this in parentheses here, so that that e to the x distributes to both of these terms, and then minus high d low, so minus sine x plus 12x, again putting this in parentheses, and then times d low, which is e to the x, and all that is going to be over low squared, so over e to the x all squared. And now from here we can go ahead and simplify this to make it a little bit easier. Notice we basically have two terms here on the numerator, these two things being multiplied and then these two things being multiplied. One term here, one term here, one term here, one term here. So basically these two products here, they both have an e to the x in common. So what we could do is factor that e to the x out of the numerator, and then it's just going to cancel with one of our e to the x's down here. So we're just going to get cosine x plus 12 minus sine x, and we can distribute the negative minus 12x all over e to the x. And this is going to be the derivative of our original function that we needed to find. Well, I hope you found this video helpful. If you did, please be sure to hit that like button down below, hit the subscribe button while you're there too, and that bell icon so you're notified of all my new videos. That way you won't leave it up to YouTube which videos you get shown, and you can learn all of calculus with me. So if you do want to keep learning about quotient rule, be sure to click on one of those videos over there. I have made a couple others. Thanks, and see you next time.